Hey everyone, welcome to the deep dive. So today we're diving into something that I know a lot of you are thinking about these days, and that's how to make those APIs, the ones I'm talking about, as secure as possible. We're talking Fort Knox level security here. Because let's be real for a second, APIs are running practically everything these days, from how we order our coffee to, I'm willing to bet even traffic lights use APIs now. It's not just about apps anymore, it's about keeping the entire digital world spinning.
It's true, APIs are everywhere, and just like anything else that's valuable, we need to prioritize keeping them safe.
Exactly. We don't just leave our valuables out in the open, right? So we've got this article here, Securing API Endpoints Best Practices. And let me tell you, it is dense. But don't worry, that's what we're here for. Consider this deep dive as our way of extracting the pure gold, the essential strategies to keep in mind. So where do we even start with something like this?
Well, I think a great place to start is always the fundamentals. Authentication and authorization, these are the first lines of defense for any API.
Right. It's like that old saying, trust but verify. Although in this case, it's more like, verify, then maybe we'll think about trusting you.
Exactly. Authentication is all about making sure that you are who you say you are, kind of like showing your ID at a club. But when it comes to APIs, things get a little more complex. We need to make sure that digital ID can't just be faked or stolen, and that's where using more robust methods like OAuth 2.0 or JWT comes in.
Okay, so you're throwing some pretty serious acronyms around now. Can you break those down for me a bit?
Absolutely. Think of OAuth 2.0, like when you use your Google account to log into a different website, you're basically allowing access without actually sharing your password. Then you've got JWT, or JSON Web Token. You can think of this as your temporary access pass with specific permissions, like a backstage pass at a concert, but digital and way more secure. It's digitally signed so you know it's legit, but it also expires after a certain amount of time just for that added security.
So it's like a digital backstage pass that eventually stops working, even if it ends up in the wrong hands. Which, reminds me of this one time. Actually, no, you know what? We'll save that story for later. But the important thing is that these tokens are time limited for better protection.
Precisely.
Uh,
And for anyone listening who's thinking, whoa, this is getting complicated, there are services out there, like Auth, that can help manage all of this for you. They take care of the heavy lifting, providing you with the tools and infrastructure to implement robust authentication and authorization without having to build everything from the ground up.
it's like having a whole security team at your fingertips. So, takeaway number one for everyone, don't leave your APIs out there like an open house. Having strong authentication and authorization is non-negotiable, and luckily there are tools and services available to make it much less painful. But even with a really strong door, you probably wouldn't send sensitive information out on a postcard, right?
You're exactly right. That's where HTTPS comes in. It's like sending that sensitive information through a secure tunnel, making sure it gets to its destination without any unwanted detours.
And I'm guessing this is especially important when it comes to things like online banking or shopping, where our personal information and financial details are at stake.
Absolutely. Every time you enter your credit card on a website, you're trusting that they're keeping that information safe. HTTPS helps to ensure that by encrypting the data during transmission, which makes it very, very difficult for hackers to intercept it.
So it's like those coded messages spies use in movies. Even if someone managed to get their hands on the message, it's just gibberish without the right key, right?
Yeah.
But how do you actually set up this secure tunnel? The article mentions something called SSL/TLS certificates, and that sounds pretty technical, to be honest.
It might sound intimidating, but it's actually become a lot easier than it used to be to obtain and install these certificates. Think of an SSL/TLS certificate like a digital passport for your website. It verifies its identity and allows for that secure encrypted connection we were talking about. And the good news is that services like Let's Encrypt offer free SSL certificates, so even smaller websites and APIs can provide that secure experience for their users.
That's great to hear. No more excuses for not having that little padlock icon in the address bar.
Exactly. It's a basic safety check, something you should absolutely see before you even think about entering any personal information.
For sure. Consider HTTPS the baseline, not a luxury. But for those who maybe want a more comprehensive approach, what are their options?
Well, you have services like Cloudflare that can take care of all things HTTPS for you. Plus, you get a whole package of additional performance and security benefits on top of that.
So it's like having an entire security detail for your online presence. Awesome.
No.
So far, we've got our digital bouncer at the door, and now our secure tunnel. It's like we're building Fort Knox brick by digital brick. But I have a feeling there are a few more pieces to this API security puzzle we need to uncover.
Definitely. Now that we've talked about controlling who can get in and how to keep communication secure, let's talk about managing that flow of information.
Hmm.
Making sure no one is trying to sneak anything past us or overload the system.
All right, you've got me intrigued, I have to admit. Let's jump right in.
So let's say you've got your API, it's secure, you've got authenticated users coming in, everything's going smoothly, and then suddenly, bam, it gets slammed with requests. Way more than it can handle at once.
Oh, that's no good. Sounds like a recipe for disaster, like a digital traffic jam. Right, everything grinds to a halt.
Exactly. And that's where something called rate limiting comes in. It's
Uh,
like having a traffic controller for your API, making sure things keep moving smoothly, and those digital pileups don't happen.
okay, that makes sense. But how does it actually work in practice? Is it literally like setting a speed limit for how often someone can access the API?
Kind of. It's about setting reasonable limits on the number of requests a single user or IP address can make within a certain time frame. This prevents things like accidental overload from, say, an automated script that's gone a little haywire, but also protects against more intentional abuse, like those denial of service attacks you hear about.
Denial of service attacks, those sound pretty scary. Aren't those the ones where hackers basically bombard a website or service with so much traffic that it just crashes?
Exactly. Like blocking all the entrances to a store so no legitimate customers can get in. Rate limiting helps to mitigate that risk, ensuring that your API can still function even if it's under a heavy load.
So it's like having a really good bouncer at the door of our API club, making sure that things don't get too out of hand. But what about the information that people are bringing in? We need to make sure that's, clean, right?
Absolutely. You don't want just anything getting into your system. And just like you wouldn't want someone sneaking something dangerous into a club, we need to make sure the data being sent to the API is actually legit. That's where input validation comes in.
Ah, so no sneaking in SQL queries disguised as usernames. I've heard those are a hacker favorite.
Definitely a concern, for sure. Think of input validation as our API's security checkpoint. It's about checking all the data that's coming in, making sure it meets the expected format, and doesn't contain anything malicious that could end up compromising the system. It's like that bag check at the door, but for data.
And I'm assuming there are tools and techniques to help with this kind of thing because manually checking every single piece of data sounds impossible.
You're telling me you'd need a whole army of people. There are tools like NGINX and Apache, which are often used as web servers, but have pretty robust features for rate limiting as well. And then you have more specialized libraries like OWASP ECPI, which is designed specifically to help developers build more secure applications and includes some really strong input validation mechanisms.
So we've got a whole security detail analyzing data at the micro level now. This is amazing, but I have to say, securing an API is starting to sound less like building Fort Knox and more like running some high-tech, high-security operation.
You're not wrong. But just like in those high security operations, we have specialized teams for different aspects of security.
Right.
And the same goes for API security. There are tools and services out there to help you manage everything.
Okay, that's reassuring. And speaking of specialized teams, the article mentions something called an API gateway. What exactly is that all about? I have to admit, the name makes me think of some kind of futuristic portal or something.
It's kind of like that, but instead of transporting people, it's all about managing your APIs. Think of it this way. Imagine a large company with tons of different departments and buildings. You'd want one central point of access to control who comes and goes, right?
Right, like a receptionist who can direct people to the right place.
Exactly. An API gateway acts as that central hub for all your APIs, routing requests, enforcing those security policies we've been talking about, and even transforming data between different formats.
So it's like the conductor of an orchestra, making sure all the different instruments are playing in harmony.
I like that analogy. API gateways are all about making sure things run smoothly and securely between your services and, well, the rest of the world. And for those already working with cloud platforms, services like AWS API Gateway offer really powerful cloud-based solutions for managing APIs at scale.
So no matter what size you are, there are options out there. This is great. We're really getting a comprehensive look at API security here. But before we get too far ahead of ourselves, I have to ask about something that's been on my mind. We've talked about all these external safeguards, but what about the stuff we don't see? The behind-the-scenes elements that are just as important for maintaining a secure system.
That is a great question. And it's something that often gets overlooked. We've talked about the front door and managing the flow, but what about making sure those walls are strong? No cracks in the foundation. That's where things like cores, Strong encryption, and we're talking really strong here, and of course good logging and monitoring practices all come in. Those are the unsung heroes of the API security world.
Okay, yes. Core. I remember that coming up. Give me a quick refresher, though. It's one of those things that can easily slip your mind until suddenly you have a security issue on your hands.
Core's right. It's like you don't want just any website out there embedding your content or making requests to your API without, asking permission first.
Exactly. Cores lets you set those boundaries. It's like saying, hey, here's who can access my API and what they can do with it. An extra layer of control, which we always like. Right, so we're not just throwing a free-for-all party for every website on the internet. But even with a guest list and, well, even with security guards, you still want to protect those valuables, right?
Yeah,
And that's where strong encryption comes in.
you got it. We talked about HTTPS for securing data in transit, but what about the data just sitting on your servers? Strong encryption, especially for things like passwords, is absolutely non-negotiable. Imagine if, despite all your best efforts, someone did manage to breach your defenses and access your database. You wouldn't want to hand them a neatly organized list of passwords, right?
Oh, that would be a nightmare. Talk about a worst-case scenario.
Exactly. That's why using really robust hashing algorithms like bcrypt, for example, is so crucial. It basically transforms those passwords into this jumbled mess of characters that are virtually impossible to decrypt, even if someone does get their hands on the hash data.
It's like putting them through a code machine, right? Useless to anyone without the decryption key. But even with all that in place, you still need someone keeping an eye on things, constantly monitoring for any suspicious activity. That's where logging and monitoring come in, I imagine.
Absolutely. Think of logging like your API's security camera footage. It keeps track of who accessed what, when, and from where. So if something does seem off, you can retrace your steps, see if there are any patterns or anything that stands out.
It's like having a detailed logbook just in case you need to go back and figure out what happened.
Exactly. And then you have monitoring, which takes things a step further. It's about actively analyzing those logs, often in real time, to catch any suspicious patterns or activities that might suggest an attack.
So it's like having that security guard actually reviewing the footage from those cameras, ready to sound the alarm if something doesn't look right.
Precisely. And the good news is there are tools out there that can help automate and streamline this entire process. Services like Loggly, Splunk, Datadog, they provide that centralized log management and monitoring, giving you a really comprehensive view of your API's overall security posture.
I never realized how much was happening behind the scenes to keep these systems safe. It's definitely a team effort with
Yeah.
different technologies and approaches working together.
It really is. And speaking of teamwork, even with the best tools and the most solid practices in place, nothing quite replaces having an expert come in and really put your systems to the test. That's where the idea of security audits come in.
Right. Security audits, it's like having a professional come in and do a thorough inspection to make sure everything is up to code, so to speak.
Exactly. Security audits are all about systematically reviewing your API's code, its configurations, even the infrastructure, to find and hopefully address any vulnerabilities before someone else can exploit them.
Like having a security consultant give your API a clean bill of health.
Precisely. They can spot those weaknesses you might have overlooked, help you assess your overall security posture compared to, industry standards and best practices, and just provide some really valuable recommendations for improvement.
Regular security audits, it's like getting that regular maintenance check to make sure everything is running smoothly and, more importantly, securely.
Exactly. And it's not just about finding and fixing problems, but also about thinking ahead. You want to anticipate what those new threats might be and be ready to adapt your security measures as needed.
Like that saying, always be a step ahead of the game.
Exactly. And speaking of staying ahead of the game, there's one more piece of the puzzle I want to touch on, and that's content security policies, or CSPs as they're often called.
Ah, yes, CSPs, right. Those are all about controlling what content can be loaded on what page, right? Like setting boundaries for your browser.
Exactly. Think of a CSP like a set of rules you're giving your browser. You're basically telling it, okay, you're allowed to load resources from these specific sources, but anything else is off limits.
It's like saying, hey, browser, be ticky. Don't trust everything you see.
Precisely. It helps prevent a whole category of attacks, things like cross-site scripting, where attackers try to sneak malicious code into your web pages. By setting clear boundaries, you significantly reduce the risk of something like that happening.
So it's like that extra layer of defense at the browser level, making it much harder for those malicious actors to do any damage. And this is something that's relatively simple to set up.
It can be as simple as adding a few lines of code to your web server configuration. And of course, there are tools like helmet.js we talked about earlier that can help make that process even easier.
Helmet.js, our security sidekick. It's like having a trusty companion throughout this entire deep dive into API security.
It really is. And it just goes to show that there are so many powerful tools available to help implement these security best practices. You don't have to do everything from scratch or reinvent the wheel.
I love that having a whole toolkit at our disposal. This deep dive has been amazing. We've gone from the basics of, authentication and HTTPS to some pretty advanced concepts like CSPs and those security audits. It's clear that API security isn't just one thing, but rather a series of layers that all work together.
It absolutely is. And it can definitely seem overwhelming at times with so much to think about. But remember, the most important thing is just to start somewhere. Even taking those first few steps, like implementing strong authentication, making sure you have HTTPS in place, having a system for input validation, that's huge.
No more excuses for neglecting those basics. Start with the foundation and build up from there.
Exactly. And don't ever hesitate to reach out for help. There are tons of resources, great communities online, and even professionals who can guide you along the way.
Couldn't agree more. API security is a journey, and like any journey, it's always better to have a map and a good guide to help you navigate. So, to all our listeners out there, remember that securing your APIs is an ongoing process, not a one time thing. Stay curious, stay vigilant, and until next time, keep diving deep into those fascinating topics that are shaping the digital world around us.